Triangle similarity postulates. In this lesson, you will prove triangles are similar using one of three similarity postulates, and there are only three: angle, angle, side, side, and side, side, side. I think the easiest one to look for is the angle, angle similarity postulate. It looks like this. You'll see a diagram of two triangles. You'll see markings having to do with angle measures of two of the angles of these triangles. You can tell that the triangles are not congruent. One is bigger than the other. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar by angle, angle. Similar just means one is a scaled up version of the other. We prove similarity using three similarity postulates, angle, angle being one of them. In other words, if angle A is congruent to angle F and angle B is congruent to angle G, then triangle ABC is similar to triangle FGH. Notice the symbol we use for similarity. Let's move on to side, angle, side. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then these triangles will be similar by side, angle, side. So in the example that we see, if the ratio of our S over XY equals the ratio of ST over YZ, and angle S is congruent to angle Y, then triangle RST is similar to triangle XYZ by side, angle, side similarity. Last postulate is side, side, side. And exactly as it sounds, we need information about three sides of one triangle and three sides of the other. If the corresponding side lengths of these triangles are proportional, then the triangles are similar by side, side, side. So we start off by writing the ratio. Three ratios. If JK over MP is equal to KL over PQ. Notice in the diagram, we're looking at ratio of corresponding sides. And if that ratio is equal to LJ over QM, then triangle JKL is similar to triangle MPQ by side, side, side similarity. So let's use these three similarity postulates and consider a diagram and decide, can I make a claim? Can I write a similarity statement involving these two triangles using one of the three postulates? So this diagram is strange because the little triangle AEF is sandwiched inside the bigger triangle. So sometimes it's a good idea to pull these triangles apart and redraw them, resketch them, realizing that angle A is congruent to angle A. And now we look at the ratio of corresponding sides. So let's look at the ratio of 9 over 13.5. And let's see, is that equal to 10 over 15? Well, if it is, then the cross products are going to be equal. So let's look at our cross product. 9 times 15 and 13.5 times 10. In fact, those cross products are equal. They both equal 135. And we have the included angle between the sides that are congruent. Therefore, we can say that triangle AEF is similar to triangle ACB by side, angle, side. Take a look at the next one. Can we say that these triangles are similar? And by which postulate? Well, one thing I noticed, there is nothing about angle measures there that is given. The only thing we can see are side lengths. So it's a good idea to look at the ratio of corresponding sides. And I like to look at the short side over the short side, then the medium side over the medium side, and the long over the long side. Do these fractions all simplify to the same fraction? Well, 14/10, I can divide both of those numbers by 2 over 2, and I get 7/5. What about the other two fractions? What did they simplify to? Turns out they all simplify to the same thing, therefore the ratio of corresponding sides is equal, and triangle CAB is similar to triangle DEF by side, side, side similarity. We'll look at another example. And here we have a small triangle above a larger triangle, and we have to figure out, are they similar? Well, once again, I like to consider these triangles separately. And I realize that angle R in each triangle is going to be congruent because in the original diagram, they were vertical angles. Now I look at the ratio of corresponding sides, and I look at short side over short side, and then longer side over longer side. Do these fractions simplify to the same ratio? They both simplify to a third. So once again, by side, angle side, we can write a statement that triangle RQP is similar to triangle RTS. Pay special attention to the order of the letters, right? And we have another example for you. This one looks very strange because I don't see angle markings and I don't see side lengths. But here's what we know. We know that vertical angles are always congruent. We also see two sides that are parallel because of the red arrows there. And you can look at WY almost like it's a transversal passing through those parallel lines. And you know that alternate interior angles are congruent. So we actually can state that these two triangles are in fact similar by angle-angle similarity. Triangle WVZ is similar to triangle YVX. And one last example for you. Write the similarity statement using either angle, angle, side, or side, side, side. Hopefully you are spotting the fact that there's a scale factor that takes the smaller triangle to the larger, and the scale factor is 2. And so every pair of corresponding sides has the same ratio. So therefore, by side, side, side similarity, we can say triangle CBA is similar to triangle RQP.